This video includes knowledge that is necessary to work safely with methyl isocyanate. This includes health and safety information, information regarding fires and MIC, reactivity of MIC, and storage and handling considerations when working with MIC. Bhopal, India, December 3rd, 1984. This accident is known as the worst industrial accident in history. 40 tons of methyl isocyanate leaked from Union Carbide's plant in Bhopal, killing 3,800 people immediately. Estimates say that 10,000 people were killed within the first few days, and 15,000 to 20,000 died prematurely in the next 2 decades following the incident. In the aftermath, Union Carbide paid a measly $470 million, $1 billion adjusted for inflation, in compensation. As well, in 2008, Bayer Crop Science had an accident involving methyl isocyanate, killing 2 employees. At the time, Bayer Crop Science was the only company that stored large quantities of MIC. Following the incident, they ceased their production of carbamate pesticides in 2012. Methyl isocyanate is an important intermediate in the manufacturing of certain insecticides. These insecticides include aldicarb, carbaryl, carbofuran, and methomyl.
When working with MIC, it is important to use the proper PPE. While working with MIC, you should wear a full body suit so no skin is exposed to MIC. Also, it is important to wear a face shield and respirator so the lungs and eyes are protected. If you come in contact with MIC, you should shower immediately and throw away the exposed clothing. Within the work area, a shower and eye wash should be nearby in case of accidental exposure.
Methyl isocyanate is given a 3 on the NFPA rating. This signifies that the flash point of MIC, which is lower than 20 degrees Fahrenheit, is low enough to readily ignite the substance if it is exposed to a heat source. Due to the flash point, it contains a risk of forming a vapor cloud as well. With the density of MIC's vapor being greater than air's, the vapor cloud will accumulate near the ground. If a heat source is found by the vapor, ignition will occur and the vapor cloud will spontaneously combust.
Well said, Austin. To add to that, if a vapor or liquid trail is formed and finds an ignition source, a backflash could also occur, leading to violent explosion of the container or leak source. If heated to decomposition, the fumes will emit toxic nitrogen oxides that are capable of causing respiratory effects. Furthermore, MIC will have a violent exothermic reaction if ever exposed to water.
Other materials that MIC will react exothermically with are acids, oxidizers, and catalysts. Due to these heat-producing reactions, runoff into sewers are capable of creating fires and explosion hazards. Also, the reaction could overpressurize and potentially rupture or explode a storage vessel.
If such a vessel explodes, it will cause a large spill. A large spill will need to be cleaned up, but in order to do this, all heat sources must be removed and the equipment must be grounded. And also prevent any water from coming in contact with the spill. Water, however, may be used to divert vapor clouds and reduce vapors. But don't allow this water runoff to come in contact with the spill or run off into the sewers.
In case of a facility fire, ensure that an emergency alarm is activated if safety is not compromised in doing so. If MIC is being released, a chemical alarm is activated to alert individuals of the spill and potential of a vapor cloud. For firefighting procedures, enter the area with extreme care due to the health hazards. Full protective clothing must be worn, including a breathing apparatus. All skin should be covered from exposure. Ensure that no water enters a storage container.
For containers that are exposed to flames, spray cooling water on the container and continue to do so until the heat source is extinguished. If a pressure safety valve is released, evacuate the area immediately. And for small fires, use dry chemicals, carbon dioxide, water spray, or fog. And for large fires, use water spray, fog, or foam. MIC is stable when it is held in a cool and dry environment, away from water, acids and bases, iron, tin, and copper, and other catalysts. If introduced to these materials, it reacts violently and exothermically to produce dimethylurea and trimethylgret, as well as gummy polymers. The reaction is relatively slow at temperatures below 20 degrees Celsius, becomes more violent when temperatures increase or acids and bases are introduced. MIC also decomposes to nitrogen oxides when it is heated. Inhalation is the major route of exposure to methyl isocyanate. The vapors are readily absorbed through the lungs. Odors of methyl isocyanate may not provide adequate warning of hazardous concentrations because the immediately dangerous life or health limit is only 3 parts per million, and the threshold for detection of methyl isocyanate vapors ranges from 2 to 5 parts per million in humans. Acute exposure to methyl isocyanate may result in respiratory tract irritation, chest tightness and pain, or asthmatic behavior. If someone is suspected of inhalation, do the following.
If exposure of methyl isocyanate is suspected, first, move the victims to fresh air. Emergency personnel should avoid self-exposure to methyl isocyanate at all times. Evaluate vital signs, including pulse and respiratory rate, and note any trauma. If no pulse is detected, provide CPR. If not breathing, provide artificial respiration. If breathing is difficult for the victim, administer oxygen or other respiratory support. Then, obtain further instructions from the local hospital. Finally, transport the victim to a health facility.
MIC can be absorbed through the skin. Severe eye irritation can result from exposure to methyl isocyanate vapors or the liquid itself. Symptoms may include immediate eye pain, lacrimation, photophobia, and corneal ulcerations. Ocular exposure may result in long-term eye damage, and methyl isocyanate is a skin irritant and can cause chemical burns when high exposure levels are reached. To treat someone that has been exposed, do the following.
In the case MIC comes in contact with eyes or skin, first, remove the victim from exposure. Emergency personnel should avoid self-exposure to methyl isocyanate at all times. Then, evaluate the vital signs of the victim, including pulse and respiratory rate, and note any trauma. If no pulse is detected, provide CPR. If the victim is not breathing, provide artificial respiration. If the victim is breathing, but it's labored, administer oxygen or other respiratory support. Then, remove the contaminated clothing as soon as possible. If eye exposure has occurred, eyes must be flushed with lukewarm water for at least 15 minutes. Wash exposed areas of the skin twice with soap and water, and then obtain further instructions from the local hospital. Finally, transport the victim to a healthcare facility if needed.
Just some other things you'll need to know about working with methyl isocyanate. It's important to have a hot work permit if doing work in the area. A hot work permit is needed if you're soldering, welding, even grinding, anything that can produce sparks. Also, it should be stored in an electrically classified area. This means that any motors, pumps, etc. have to be explosive proof. And if you have a cell phone or any other electronic device, you need a hot work permit as well to have that within the area. Also, MIC should be stored in a stainless steel vessel that is above ground so you can see the whole tank, and it needs to be kept below 40 degrees Celsius.